Section 9.2 Vectors in R3. Because we live in a three-dimensional world, it is essential that we be able to visualize surfaces in three dimensions. To that end, we considered other triples and their representation in three-dimensional space, as well as developed some knowledge of simple three-dimensional surfaces, namely the quadratic surfaces. We have already considered other pairs in R2, and because we live in a three-dimensional world, it is also important to consider a three-dimensional system. We call this tree space and denoted it by R3. We introduce a coordinate system to tree space by choosing three mutual perpendicular axes to serve as a frame of reference. The orientation of our reference system will be right-handed, in the sense that if you stand at the origin with your right arm along the positive x-axis and your left arm along the positive y-axis, your head will then point in the direction of the positive z-axis. The algebra of vectors in R3 is the same as in R2. In R3, each vector has three components. For example, a vector with three components, 3, 6, and minus 4 respectively, may be expressed as the sum 3i plus 6j minus 4k. In this representation, I, j, k are the standard basis vectors in the direction of positive x, y, and z axis respectively. Since R2 is the horizontal plane, the z direction will be up and down direction. The formula to calculate the magnitude of a vector is similar to R2. Given a vector with three components, 3, 6, and minus 4, the magnitude of this vector is the square root of the sum of three squares. So the result is square root of 61. Using the formula for the length of a vector, we can set up the equation of a sphere. A sphere is defined as the collection of all points located a fixed distance, called the radius, from a fixed point, called the center. In particular, if P, X, Y, Z is a point on the sphere with radius R and center C, A, B, C, then the distance from C to B is R. Thus, R equals square root of x minus a squared plus y minus b squared plus z minus c squared, implying the equation of the sphere is x minus a squared plus y minus b squared plus z minus c squared equals r squared. A sphere may be centered at a point other than the origin, and the resulting equation may look different. Show that the graph of the equation x squared plus 6x plus y squared plus z squared minus 5z plus 7 equals 0 is a sphere, and find its center and radius. By completing the square in both variables x and z, we have x plus 3 squared plus y squared plus z minus 5 half squared equals minus 7 plus 9 plus 25 fourths. The right hand side of this equation is 33 fourths. Comparing this equation with the standard form, we see that it is the equation of a sphere with center minus 3, 0, 5 half, and the radius square root of 33 fourths. This is the end of this section. Thanks for watching.